Okay, so now that we've seen how we can still answer function, relation, domain, and range given a graph, what about function notation? So recall again, when we're talking function notation, we're replacing the y with a function notation. In this case, I have a function, its name is g, and this function depends on x. So this is just a very fancy way of saying y. And then again, we're talking with the notation, I can tell you that we're inputting it and finding the output. Like here, x is 0. What's the output? What's the y value when x is 0? Here, what's the output when the input's -3? And here, what's the output when x is -7? As opposed to the next round, this is essentially saying y is 0. So we got to go find x. Y is -2, right? The output's -2, so what's the input? The output's +3, so what's the input? So be careful with the notation, and here's how we'd use a graph. You basically just read it, right? So for this one, we're told that x is equal to 0, and we're essentially asked to find y. That's what the meaning of that function notation is. So I'll just go to my graph, go where it says x equals to 0 right here, and it looks like the corresponding output is -5. So g of 0, based off of that graph, is -5. What about g of -3? Well, again, meaning-wise, I'm telling you the input's -3, and we're asked to find the output. So I'm going to go to my graph. Here's -3, and it looks like it's crossing the x-axis. So it looks like 0 would be the value, right, at -3, given the graph. So y is 0. G of -7, well, again, notationally, I'm telling you the input's -7, and we're supposed to find the output. When I go to the graph, here's x equals to -7, but I don't see a graph associated with it to it, right? So that essentially means this is not in the domain, which means that this, the correct answer here, would be undefined. The function is not defined for an input of -7. It's not in the domain. So undefined, if it's not there, it's not there. Now you're right, I can guess it, right? Assuming this goes out this way, I could guesstimate what it is, but for the function notation, I want to know exactly what it is. There's got to be a way to find it. And in this case, I can't, because we don't really know what's happening. It's a guess. Changing gears, g of x equals to 0. Well, this time I'm telling you the output is 0, and we're supposed to find the input. So I'll go to where y is equal to 0, and I notice that there's basically 3 locations where y is equal to 0. It looks like x equals -5, x equals -3, and x equals +3. So there's actually 3 input values that create that output of 0. And again, that doesn't mean we're not a function, right? Because 1x, 1y. This x, 1y. This x, 1y. And you can even see it passes the vertical line test. So there's 3 values, there's 3 input values that create that output of 0. In the next one, g of x equals -2. Well, I'm basically telling you that y is -2. What's the x coordinate? So I'll go to where y is 2, go look at the graph, and it looks like there's 2 values. One of them looks like -2, and the other one looks like +2. Right? So those are the 2 pieces of input that create an output of -2. The next graph, next one, we have g of x equals to 3. Again, figuratively speaking, that means y is 3, and we're supposed to go find x. But when I go look at y equals to 3, there's basically no graph. There's like this gap in this piecewise function. There's no input that's associated with that output. So this, again, would be undefined. All right? It's not in the range. 3 is not in the range, so since it's not in the range, nothing's going to give that output. All right, so there you have it. So again, doing the same thing we did back in 3.1, but rather than plugging it into a function or reading a schematic or reading a table, we're basically gathering our information from a graph. So same difference. G of 6 minus g of -1 and 6 over 6 take away -1. Well, again, g of 6, right, that kind of takes us back up here. I'm going to go look where x is 6 and go find the corresponding y value. Well, it looks like it's 6. G of -1, Well, I'm going to look at x equal to -1 and go look at its corresponding y value, and that looks like it's -4. So now that I found those two outputs, what we basically have here is 6 take away -4 all over 6 take away -1. The top is 10, the bottom is 7, so that funny little thing there creates 10 over 7. And again, if you look at the point here and the point there, what we're actually finding is the slope of that line. 1, 2, 3, 4, 5, 6, 7, right? So there's a run of 7. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's a thing of 10. So this is basically your slope in function notation. Last but not least for this video, let's go ahead and take a look at can I find the y-intercepts from that graph? Well, yes. Right? By y-intercepts, we're looking at places where we're crossing the y-axis. So if I look, right, it looks like we're crossing it right there. That seems to be occurring at 0, -5. Can we find the x-intercepts of this graph? Well, you bet, right? Because again, this is where we're crossing the x-axis, and we've already kind of handled that up here, but it looks like we're crossing the x-axis at 3 locations. At -5, 0, at -3, 0, and at +3, 0. So there's a relook at some old things, if you would, done with a picture, right? Evaluating function inputs, finding function outputs, if you would, all right? And then evaluating what's a slope, and then finding intercepts. All things we've done before, but now we're doing functionally with function notation where the function is given as a graph. All right, more to this story. There's some new things that we'll have to talk about, but I'm going to basically cut to a new video to do that. See you guys then.